Hi everyone, this is Abhiyan.
And this is Binit.
So this is our final project for Computer Organization 1. The final project is basically to dynamically allocate memory in MIPS and then test it with HipCert. So we researched on how to dynamically allocate memory, and then we came to know about two functions in C. Those are the malloc and free functions. Now we are going to briefly discuss about malloc and free in C. So the malloc function takes in a size and dynamically and allocates that amount of memory in the heap. So in our case, we ask the user for n number of integers, and then we calculate the number of bytes that number of integers would occupy, and then we allocate that memory in the heap. Um, the free function. Benit is gonna say something about it.
Okay, so now about the free function. So when a pointer is passed to the free function, free is supposed to free some memory. However, since we just get the pointer, so we may not know what size the memory is that we should free. So in that case, we can store some metadata to give an idea of when we can mark free. So we also need to calculate if there is enough memory for us to free and then malloc. If not, then we need to extend the heap and perform malloc.
Now we know about malloc and free. There are other helper functions that help us to properly allocate memory and then access it and traverse through it and read data. Um, so if you consider dynamic allocation as thinking of it as like a linked list, you could have size and the pointer and the free marker in the meta block, and then that meta block would help you to identify and check if you find a free block, or if you need to request some more memory in the heap. And other functions, there are other functions that can be used. Those are the calloc and realloc functions, but we have not really made use of them, but those functions help us to build a robust solution in terms of dynamic memory allocation. We implement this concept in MIPS, and along with that we are attempting to um, implement the HipCert algorithm. So HipCert algorithm basically heapifies the number of items that is provided, and then basically from the heap it it pops out the smallest number if you want an ascending order, ascending sort, or the largest number if you want a descending sort. So this is just a summary of what we had to do for the project. Now I'd like to go over the implementation of the project. So this is a simple implementation of the malloc. So first of all, I um, take the pointer of the first heap um, through the aspect 0, and then I call the user input. Now, once the user passes the number of elements and the number they want to input, I'll simply malloc them. I'll simply calculate the number of elements and the bytes required, and then I'll malloc that size, and I will also allocate the numbers into the memory accordingly. So, and then I traverse through the malloc using the head pointer, and then access the numbers that are recorded in that malloc. So I'd like to go over a simple run through of this. Just a small error here. So I'll run it. Let's say 3, 1, 2, 3. There you go. There are 3 numbers that we just inputted. So let's go over the main part of the project, that is the HipCert.
Okay, so we worked on the HipSort algorithm on our previous project, project 4. So that HipSort algorithm was implemented on static array. But while in this code we combined our malloc functions with the existing heap sort algorithm to uh, to implement it dynamically. We made some changes to accommodate proper running of the programs. So the malloc function looks something like this. So now our program asks the user for input. It stores the integers dynamically in the memory, which we can traverse, and if we want, we can print it out.
So now let us go through a run through of the program. The heap set algorithm is here. Let's run it. Symbol.
So we're taking three integers. So the first one will be 4. The second one let it be 1, and the third be 2. So there
So
it
we have
is.
the three items here, 1, 2, and 4, along with the addresses that are that they are stored in. So this is how our heap sort algorithm worked. Still have a lot of things that we could do. We could make some progress on this heap sort algorithm. We have not yet properly implemented the free functions, and we could also make it more robust by using the calloc and realloc. Let us also go through performance check for the heap sort algorithm. We have not actually calculated the overall performance from the CPI and the instruction count and whatsoever, but we can go through, we can count the number of instructions here. Let's first assemble this code. Let's go to tools, instruction counter, and then let's connect to MIPS. Let's run this code. 3, 4, 1, 2. Let's go to IO. So we have the elements here, and then the instructions so far is 263. The R type instruction, the I type instructions, and the J type instructions is reflected here. So to give you a better idea of how we kind of had an idea of the performance between the dynamic allocation and the use of arrays is shown here. So the static arrays, so when we pass 24 integer values, the static array that was the previous heap sort algorithm that we used in project 4, it took 2691 instructions, and our dynamic allocation it took about 2603. Of course this is not the exact performance evaluation, but we can get a certain idea that the dynamic allocation is better than the heap sort implementation. Thank you.